Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dokwa Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. So in this example, we want to look at question number 16 on finding the derivative of trigonometric inverse function. Now we have y equals to tangent inverse of a cos of x minus b sine of x divided by b cos of x plus a sine of x. So we're going to do this and then you can try this problem. So our answer for the first question is just y prime equals to -1. So in general, to find the derivative of trigonometric inverse function or even finding derivatives of trigonometric functions, it's not really difficult, but most times is to simplify your derivative into the answer that has been given to you. So now the answer is -1. We need to find -1. How can we show that the derivative of this is equals to -1? So several methods that we can use. But one of those methods that we're going to be using is to just apply the chain rule. That is, we're first going to go for what is within, find its derivative, and then we can use the chain rule formula. So we know that the chain rule says the derivative of y with respect to the derivative of x. Because now if we take this expression to be u, we must find the u by the x, because the variable here is x, so we must differentiate that new function with respect to x. So we're going to multiply that by the derivative now of y with respect to, because if this is now u, we want to find the derivative of y with respect to u. So this is u. Now this and this cancel, it just equals to dy by dx. So u equals to a cos of x minus b sine of x all over b cos of x plus a sine of x. Now, one important identity we're going to be using is a Pythagorean identity. That is cos square x plus sine square x is equals to 1. So this is very important, and that's it. Let me put it up here just in case there's not enough space. So this is exactly what we're going to use. So now, since this is u, now let's find our du by dx. So applying the chain rule, we hold the denominator because the chain rule says, if you have y equals to u over v, then it means that y prime is equals to v times u prime minus u times v prime all over v squared. So that is, we hold the denominator first and differentiate the numerator minus, we now hold the numerator and differentiate the denominator. So we hold this one, cos of x plus a sine of x, and then we differentiate this expression. So this is minus a sine of x, this minus b cos of x, minus, we hold the numerator, a cos of x minus b sine of x, and we differentiate the denominator. So the denominator derivative of b cos of x is just minus b sine of x, and then plus a cos of x, all divided by this denominator all square. So it's b cos of x plus a sine of x all square. So the u by dx is just equal to, so we can now multiply. Now let's multiply them one by one at least, so that we, okay. So this time this gives us minus ab sine of x cos of x, and then this time this gives us minus b square cos square x. This and this gives us minus a square sine square x, and then this and this gives us minus ab sine of x cos of x. Now let's reduce it. We have ab sine of x cos of x and ab sine of x cos of x. So we can add them. The signs are the same. So this will just give us 2ab sine of x cos of x. Okay, so let's erase this one now. Then we move to the last one. So we have this time, this gives us this and this. So it's plus ab sine of x cos of x. This time this is minus a square cos square x. This time this is minus b square sine square x. And then this time this is plus ab sine of x cos of x. So we might want to go over it. This is positive times negative is negative times this is positive. That's how we got this one, the first one. And then this and this is also positive. This gives us negative. And then this is positive. This makes it negative. And then the last one is negative. This makes it positive. So if you look at this one and this term are the same, so we can add them. So it becomes 2ab sine of x cos of x. So we don't need the last term. So this whole thing is being divided by b cos of x plus a sine of x all square. Now we can try to bring in this identity. So we look for, now let's further simplify 2ab sine of x cos of x. 2ab sine of x cos of x, positive and negative go out. Now minus b square cos square x. Now we cannot pair it with a because this is b and this is a. We cannot pair the two of them, but we can pair it with b minus b sine square x. So if we factor out minus b square, this b square comes outside. So it will be positive sine square x. That is cos square x plus sine square x. And what is it? Cos square x plus sine square x is just equals to 1. So it means that this expression and this expression is equal to 1. It's equals to minus b all square. Similarly, if we compare this and this, a square, we can just factor out the a square. The minus a square will now be left with positive sine square x plus cos square x. This is also equal to 1. So it means in the entire numerator, our result will just be minus b squared minus a squared. So the entire numerator now is just minus a squared minus b squared. So we factor out the negative, it will be a squared plus b squared all over b cos of x plus a sine of x all squared. So what we need to do, we just need to position this somewhere so that we'll be able to use it later. So let's bring it down here. So we know that du by dx is just equal to minus a squared plus b squared all over b cos of x plus a sine of x all squared. So we now go for the second one. Now we now have this. So we now need to find this. So we have what? Y equals tangent inverse of. So that entire expression now is just equal to u. So we differentiate, y prime now equals the derivative of tangent inverse of u is just 1 all over 1 plus u squared times the derivative of u. So the derivative of this one is just equal to 1 because the derivative of u is just 1, right? Now, we've now gotten dy by du. But this u, right? This u is this inner portion. So we can replace that. And then we will have a cos of x minus b sine of x all over b cos of x plus a sine of x. So because it is square, we can square both the numerator and the denominator. So we simplify this further. So this time this, so we have dy by du is equal to, so this is 1 all over. So if we multiply this and this, remember we can expand this expression. So if we expand this expression, it will give us b squared. So one of the easier way to expand this thing, you square the first term, you square the second term. So let's square the first term, b squared cos square x plus, let's square the second term, a squared sine square x. Then what we do, we multiply this and this, and we attach 2 to it, right? Because it's going to be twice. So we say 2 times this times this. So it's 2 times this times this. So b cos of x times a sine of x is just 2ab sine of x cos of x. So that's one of the easiest way to do it. All divided by this denominator, because this now will be the common denominator. So it's b cos of x plus a sine of x all square. Then we expand this as well. We do the same thing. So it's just going to be the first term all square. So it's plus a square cos square x. The second term all square. So if you square this one, it gives you positive b square and sine square x. Then you say 2 times this and this. So because this is negative, so we just be negative 2ab sine of x cos of x. So we see that the last term here can cancel this one. Then we now simplify. So dy by dx is now equal to 1 all over. Now look here. This first term, which is b squared cos square x, like we had in the previous problem, and then b squared sine square x, we can factor out b squared. So if b squared is factored out, we will just have b squared outside, then cos square x plus sine square x. So this is just equal to 1. So this whole thing now is just b squared. We do the same for this one, this and this. If we factor out a squared, we'll just be left with sine square x plus cos square x. So this whole thing is just 1. So it's just plus a squared. So let's just reduce this thing. All divided by what is under, we have b cos of x plus a sine of x all square. So you notice that this denominator can just go within the numerator. So now this our dy by dx. Sorry, this is du by dx will just be equal to b cos of x plus a sine of x all square divided by b square plus a square. So the next thing now, we just multiply the two of them. Oh, what was it? This was dy by du. Yes, dy by du. So we only replace our u. That was what we did. Okay, so finally now we can find our dy by dx. Then dy by du now is just equal to this, which is b cos of x plus a sine of x all square, all divided by b square plus a square, and then times our du by dx, which is this one now, is just minus a square plus b square all over b cos of x plus a sine of x all square. So what do you observe? Didn't this go out? So the y bar dx is just equal. Now this is also going out. So it's just minus 1. Or we say y prime is equal to minus 1. So you see, y prime equals to minus 1. That was the initial answer that we gave. So thanks ever so much for watching. Please don't forget to like, share, and subscribe. See you in our next lesson. Thank you.